So this tutorial we're going to be going over the basics of Git. We'll just sort of talk about what actually is Git, how should you be using it, why should you use it, in particular for the CS246 final project. We'll go over some of the resources that the University of Waterloo provides for Git, and then finally we'll just talk in depth about some of the commands. So the first question is, what is Git? And the short answer is that Git is version control software. The idea behind version control software is that software development is not a linear process. As you develop software, you're going to change your mind a bunch of times, you'll be collaborating with a bunch of different people, and you'll have this massive file tree that could have a ton of complicated changes being made to it every single day. Version control software is here to help make that a bit easier. Instead of you having to remember what does what and what's being changed where, we'll just set up a program to take care of it for us. And there are a couple of systems that do this. Some of the most popular ones are Subversion, the concurrent versioning system CVS, Mercurial, and the most popular, without a question, is Git. GitHub is a major reason for its popularity. Some of you may have used GitHub. Prior to doing CS246, I used to use GitHub all the time using the nice GUI Git for Windows interface and whatnot. We're going to take a more in-depth and dirty approach to it, using Git directly from the terminal. And that'll be nice because you'll really get to see a lot of the features that are built into Git, rather than just relying on the Git for Windows to do it for you. It tends to abstract away a lot of the details. So the very basics of Git, we have, maybe this is your local computer, this is your repository, and you have some code in it. And while you typically use Git together with systems like GitHub, in fact, you don't need any of these things at all. You can just have code here, you make changes to it, you update it locally, done. You get all the benefits of Git. However, where Git is typically used is in conjunction with what's called a remote. Now that's a server that's also going to keep a copy of the code you have, and every once in a while, if you feel like it, you can say, well, I have these changes, please give them to the server, or let me know if the server has made any changes. And so you could have a server here. And your code communicates to and from the server. Now you've already seen an example of this, whether or not you've really been cognizant of it. And if this code was 1189, and the server was student.cs.uwaterloo.ca, that is a prime example of a Git repository. And the way you can check that is if you actually just navigate to cd cs246/1189, and then you type git status, you'll get this big pop-up of a bunch of files that you've changed, which is what Git thinks you've done differently from the base 1189 repository. Now, if we wanted to, we could actually go through and talk about a whole bunch of Git stuff just using 1189. However, 1189 is our repository. We, the CS246 course staff, own it, and there's a lot of things that we can do with it that you guys can't do with it. So it's not a very good instructive example. Instead, what we'll do is we'll make our own Git repository. And before we even talk about this whole code server thing, we're just going to make a basic repository that handles our code only and allows us to save our work locally. So I'm just going to make a directory, and I'll do git init. That's all we need to do. We've now made an empty Git repository inside CS246 extra tutorial/foo. So one of the most basic things you can do in Git is you can make a commit. And what a commit is it's basically a little package of changes that you've done that you want to be able to send to other people, or go back in time to, or just work with. So for example, it wouldn't be very convenient if every single character you typed was a change that you could revert or roll back or anything, because you're going to type a lot of characters. It's going to get unwieldy very quickly. So a commit exists to allow you to package a bunch of changes together in what you believe is a small logical structure. Git is just going to give you the ability to do this for yourself. So we can make a commit, make a file called test.cc, and it's not going to be a C++ file because I don't feel like writing the boilerplate. We can just give it ASDFGH. So now let's see what happens when we do git status. Right, so it's going to tell us, first of all, we're on branch master. We'll see more of that later. We have no commits yet, and we have untracked files. So in the Git lingo, there are effectively two classes of files, which are untracked files and tracked files. Untracked files are the ones that Git sees exist, but Git isn't going to do anything with. It just assumes that, they're there. Maybe you don't want them to be part of your Git repository. Whenever you decide that you do want test.cc to be something that you're controlling with Git, you just need to let Git know, please keep track of this file for me. And the way you can do that, as it suggests to you right here, is git add and then test.cc. And so if we do that, we'll see that we've changed test.cc from being untracked to being changed to be committed. Among the tracked files, there's also another dichotomy between staged and unstaged changes. Whenever you make a change, it's going to show up here in one of two parts, which is this green part, or it's going to show up colored red. If it shows up colored red, that means if you commit, you're not adding it to the commit. Whenever you make a change, anytime you make a change, if you want to add it to your next commit, you have to use this git add command to tell Git, not only have I made a change to this file, I want you to include this change in my next commit. And we can see here just by this output, test.cc, it has been added to this commit, and it will be added if we commit now. So we can make a new commit, and the command is pretty intuitive. We say git commit. It does take an argument now, and the argument is -m, and M stands for message. So anytime anyone down the road looks at this commit, they're going to see this little message along with it, as well as the time that it was made, the files that you changed, who made the commit, just a bunch of useful info. So we can do this. And now if we check out our status, we see that there is nothing to commit, working tree clean, which means there's nothing that's changed. What Git thinks the repository looks like is exactly what the repository looks like. So that's great. Now, one thing you might want to do is you might want to delete a file. You might want to rename a file. You might want to copy a file, all these things that you're used to doing in the Linux shell. Git makes it very easy to do those while keeping track of those files with Git. So for example, if you were to copy a file, Git's going to see it as a new untracked file. Then you'll need to add it in, and you'll need to commit it, which is rather messy. Instead, if you just put git before the command, Git will automatically figure things out for you. So I could say git, for example, move test.cc to test2.cc. And now if I git status, Git has recognized, since I used git move, that we've changed test.cc to test2.cc. Now just for example, if we were to not use git move, it would still recognize this, but it would take it a bit more effort. So we could say move test2.cc, test3.cc. Now Git thinks that we've deleted test2.cc, and we have an untracked test3.cc, which is a little messy. But if we add both of these to our changes, it will recognize that it was just a rename. Like so. And we can commit this again. And most shell commands that you find yourself using regularly, like copy, move, remove, they'll all work with this pattern. You can just say git before them. It'll figure it out for you. Now this is great and all, but this isn't how people use Git. You can use Git like this. But really, whenever people think about Git, they think about putting their code online, on GitHub, or Bitbucket, if you will. And so, in order to really look at Git, we do need to add in this server aspect to things. And before we talk about that, let's talk about the different kinds of Git servers. The most popular one is GitHub. GitHub, everything you post is public by default. There are private repositories. You have to pay for them, unless you have a student account, which gives you 2 or something. It's been a while since I looked. When possible, do not use GitHub in this course, because we have a better alternative. Coming to you free with the price of tuition is the UWaterloo GitLab. At git.uwaterloo.ca. So if I sign into this, you can see these are all my repositories. I can make new ones up here. And moreover, as a student of the University of Waterloo, I get 10 free private repositories. So, if you want to use Git for your final project for this course, which I highly recommend you do, I also highly recommend that you do it through the UWaterloo GitLab. So we can take a look at making a project in here. It's very easy. You just click the big green button that says New Project. And it's going to prompt you for all this information. So project name, I've used My Awesome Project and My Awesome Project 2 for running this tutorial in the past. So I suppose we will move on to My Awesome Project 3. And, oh, I didn't mean to click it so quickly there. But at the bottom of the screen, when you go through that interface, you'll also get this additional thing that says, do you want to make it private, public, or global? The difference is being private is visible to only you. Public is visible to only members of the University of Waterloo who have this GitLab account. Global is visible to everyone. There's also a way that you can use GitLab with a group, for example, your final group, your group for your final project, rather. And we will take a look at that in a bit. But for now, we'll go through things. So down here we have command line instructions, which, if you're not familiar with Git, is the primary way you will find yourself using Git throughout your life, as much as I'd like to believe otherwise with this tutorial. Here are these lines of code that I found on the internet. I'm going to copy them and paste them into my terminal without wondering what they do. And if all goes well, it'll do exactly what I want it to. I want to create a new repository. I want to create my awesome project 3.git. So here we go. Oops. Oh yes, this doesn't like working. I'll type it in manually then. So the first command in this list, oops, it's loud. The first command in this list is git clone. What git clone says is, at this URL, there is going to be a Git repository. I want you to go there, and I want you to get it for me. Syntax is very simple. You just say git clone and then the URL. In this case, we have this. Now, since it's a private website, or since it's a private repository, it is going to ask for my username and password. These will just be your GitLab username and password. Warning, I appear to have cloned an empty repository. Indeed, I have. So now I have my repository here. And the nice thing about cloning is that this is automatically linked up to the server. And what that means is if I were to make a commit here now, I have to add it, and then we can check git status to tell me everything's fine. And now we have this command here right at the bottom, push-u origin master. And what this is going to say is it's going to say, OK, I want you to take what I have here. I want you to go to origin, which is my server, and I want you to push it to master there. You only have to do this the first time. Every time after, all you need to do is type git push. It's going to be smart enough to figure out you probably want to go to the same server you did last time. But for this first step, git push-u origin master. It'll ask you for your username and password again. And in fact, it'll always do this. You can add in SSH keys, which will automatically track your authentications. And you'll never have to type in your username and password again. I won't go into that here. And one thing you can notice right here is we say branch master, set up to track remote branch from origin. So that means our local Git repository is now going to be tracking what happens on that server. We never have to do that origin master step again because Git has it figured out. Now what's nice is if we go back to our web interface, we can now see test.cc. So what we've now done is we have pushed it onto the internet. Private to us, but still on the internet. Now it's starting to get more useful. In addition to git push, hopefully we'd have a command to get changes from the server. And in fact, there are two with subtle differences between each other. Git pull, all you need to do is just type git pull, no additional arguments. And you've been using this one throughout the term to get new assignments. Says, go to the remote server here, ask if anything's different. If there are new changes that I don't have yet, download them to me locally, and then merge them into my current code. That's a lot of stuff. However, if you've made no changes to your code and you just run git pull, all it's going to do is it's going to say, OK, I'm just going to get everything that's changed, and I'm going to give it to you. There's also a command git fetch. Git fetch is very similar to git pull, except it doesn't do the last step of making changes to your code. All git fetch does is it downloads the changes that have been made on the server, and it brings them to you locally. You're then free to do with them what you will. We'll see that in a little bit. All right, so what we can do for fun now, let's make another clone of this repository. So we'll have two of them right beside each other. And we can just take a look at using git push and using git pull to send files between them. And I promise this is cooler if you're working on two different computers. It's not very interesting on the same computer. So first thing we want to do is a git clone. And it was something like git.uwaterloo.ca. Yeah. I'll just use the autocomplete. It's easier. Oops. All right, so now we have another copy of my awesome project 3, and you can see that right away we have our test.cc added in here. So now the first thing we might want to do is we'll say, okay, well, we'll make a change here, we'll push it, and, well, then we'll try pulling it from our other copy. We add in test.cc because we've changed it and we want to let it know this should be in the commit. Now we make a commit. And then we push. Since this is the first push for this repository, we need to remember to add in this uorigin master. All right. Now if I go back to our other repository, see we still have our old test.cc. However, whenever we run git pull, now we've got something interesting. We can see, well, there has been a change that we've picked up from master. And that change has changed 2 lines in test.cc. You might object saying, well, test.cc only has a single line. And the answer is it, quote unquote, deleted the old line and it added in a new line in its place. That's just the way Git likes to think about it. And if we cat this test.cc, we can see that it does have the changes in. Now here's a bit of an annoying situation that you hopefully won't have to run into too frequently. In our other repository, we made changes to test.cc and we pushed them to the server. What if, when that was happening, I was making changes to test.cc in this repository? How would Git know which version of the changes were good? Since I have my local changes, and now when I run git pull, recall it's downloaded those changes from the server, and it's going to try to merge them into my current code. But if we have 2 sets of changes, Git will have to decide which one is better. And the way it does that is by not deciding. Git's not a mind reader. It's not going to be able to tell which line of code is the right one for a program. If Git can't figure out what it wants to do, it's going to tell you, and it's going to say, fix it for me. And you'll have to fix it before Git will let you do anything else. This undesirable situation is called a merge conflict. Let's make one. So there are 2 ingredients for a merge conflict. The first thing is we need to update the code on the server, and then we need to update our own code locally, and then we need to try to pull. So we'll do that like this. We'll add in another line here. One thing you can also do if you don't like doing git add each time, you can also add the -a option to commit, which says commit every file, even the ones I haven't added. And then we can push this. Okay, now we can, in here, we can make a different change. And now, for the first thing, we've just made this change. We haven't added it to Git yet. Git isn't aware that this change has happened. If we were to run git status right now, what we'd see, Git knows that test.cc has been modified, but it hasn't been put into a commit yet, so Git isn't really listening to what modifications we've made. Now if we were to try to pull, well, we're in a bit of an awkward situation if we try to pull. Because as I had described it, Git has these 2 sets, a merge conflict occurs when Git has these 2 sets of changes, and it wants to know which one should win over the other. Here, Git doesn't have the changes to test.cc. It knows it's been changed. And so you think, well, maybe Git's just going to overwrite it. because we've changed it, but we haven't committed it. So really, we're opening ourselves up to this. That's not actually what will happen. Git is nice. It will tell you, this pull would break what you have locally. Please do a commit of it before you do this pull. That way, if something goes horribly wrong, you have backups. We can see that. And this is the message we get. Please commit your changes or stash them before you merge. All right. We'll listen to Git for now, and we will commit them. Now if we pull, we will get this message saying, conflict. Merge conflict in test.cc. Fix conflicts and commit them. And if we run git status, it'll tell us that. All right, it says we have unmerged paths, fix conflicts, and run git commit. OK. Well, we can see that both we and the server have modified test.cc. And so it wants us to fix that. How? Well, let's just take a look at what test.cc contains. Maybe we'll get a hint. Well, that's a pretty good hint. We have these A's I remember adding locally. And then this foo bar, it must be what the server thinks we have. And if you do think back, that is what we added to the server. So we want probably only one of these in this case. But in general, figuring out which of these two things you want, maybe it'll be a combination of the two, who knows? That's what makes merge conflicts difficult. In this case, I decide, yeah, my local changes were wrong. I really do want foo bar here. All I have to do is delete the lines I don't want and save the result. Now, as Git told me, I'll run git commit. Whoops. I need to add them first. And that has done the merge. If we run a git status now, we'll see that there's no issues. There we go. Nothing to commit, working tree clean. It does tell us we're ahead by 2 commits. You might find yourself asking, well, what are those commits? Because if we take a look at it, we're going to look exactly like the server. Well, it's going to look something like this. This is what we had. This was back when we had an unmodified test.cc. Then what we did is we modified it to be A, and then we pulled in something from the server, and we changed it to be foo bar. And the only reason why we have this extra commit is because in order to resolve the merge conflict, we actually did have to commit that on top of it. And so the server here is still sitting at foo bar. So really, although there's that extra layer there, these two things are still exactly the same. That's just in this particular case. If your merge conflict, you change some things but not others, well, then maybe it'll look different than the server. And then after you fix that, you probably want to run git push just to send your changes back to everyone. Say, you know what, there's a merge conflict, but I fixed it now. Here's what I've done. This was messy, and this was a single line example. You can imagine that this gets exponentially worse as your code base gets larger, as your merge conflicts span multiple files. It's a massive mess, honestly, having to deal with these. The solution is don't make merge conflicts. It sounds a little bit silly, but merge conflicts only occur whenever 2 people are working on the same file concurrently. There's a very easy way to prevent two people from working on the same file concurrently. It's messaging the other person and saying, hey, I'm working on this file, please don't. Sounds silly, but it does work. Ultimately, no version control software is going to be smarter than just talking to the people who you're working with. That's going to be key. Another thing that this sort of pushes onto you is good encapsulation. You can imagine that if you decided to write your entire CS246 final project in a single file called main.cc that was 7,000 lines long, and you had 3 people trying to work on it at the same time, and say, oh, Joe is changing lines 2,000 to 2,500, and yeah, it's going to be a pain. If instead you have your project split into 50, 20-line files, which might be a lot harder to figure out at first, but once you get used to it, you'll think, well, this is actually a lot better, because I can change this whole list of files, and these are my files. No one else will change these. We'll never have any issues. So just by splitting up your classes into logical units, that's a very easy way to avoid merge conflicts, in conjunction with talking to other people. But this whole encapsulation thing just makes it easier to not have 2 people be working on the same file, is the idea of it. And now you can sort of see, I had mentioned earlier, the difference between git pull and git fetch. Git fetch downloads these changes. It does not run a merge, which means even if there were merge conflicts that would happen if you ran git pull, you won't get any merge conflicts if you run git fetch. It'll just download those changes locally and it won't do anything with them. Once you have those changes, you can run the command git merge. Git merge will try to merge them together, and if there's any merge conflicts, they will occur when you run git merge. In fact, git pull, pretty much all it does is it runs git fetch and then it runs git merge. It's just some syntactic sugar over that. In lots of larger companies, larger code bases, you will occasionally see it split up, and you'll fetch and then you'll merge. Or an alternative is you'll fetch and then you'll rebase, which we probably won't talk about, but I encourage you to look it up if you're interested. However, whenever working on smaller projects like this, you usually can't go wrong by just pulling. It's easier, you don't need to think about the particulars, and if you're communicating well, you won't ever run into any issues with merge conflicts. All right, so this is all interesting, but still, really, what have we gained? I mean, sure, we have the ability to share code between people, but we could have done that before, couldn't we? I mean, all we need is a Dropbox, and every couple minutes, everyone uploads their zip of the most recent changes they've done. It sounds ugly, but is it really that much worse than what we're doing now? Sometimes you'll break things. Sometimes you'll think you should do one thing, and then realize later that it was a really dumb idea to do that thing you thought you should do. And at those times, you might be wondering to yourself, if only Git had a magical time machine that I could go back in time, back to before I made these stupid changes, and everything would all be wonderful. And of course it does. Otherwise, I wouldn't be talking about this. In order to use Git's magic time machine, which comes in a couple forms, first we need to, well, know what can we go back to. There are 2 commands to help you out for that. The first one is called git log, and the second one is called git reflog. The only difference between the 2 is that git log gives you commit IDs, and git reflog just tells you this happened n commits ago. Like this commit was however many commits ago. Like so. All right. So we can see a couple of recent commits that happened. If you'll recall, we modified this test was making test.cc. This test was modifying test.cc. And then we did that merge, and we had to commit the merge that we did. And so this is that commit where we merged the changes from the server. So those are the 3 previous commits. All right. I changed my mind. I don't want foobar. I want my AAA back, and I don't want to type it out. I want to be back here. Modified test.cc, that's where I changed, or that's where I added the AAA. So this is the magic number, depending on what base you're thinking in. E6696083, etc. And we want to tell Git, please go back to this commit and get me test.cc, because that's the test.cc I want. The command for that is called git checkout. You say git checkout, and then you say a file, and what it'll do is it will go back to that commit, it will grab the file, and it will bring it to where you are now. I forgot to copy the commit ID. You usually don't need the whole thing. Git's smart. If you just take the first couple characters, Git will say, well, there's only one commit that could be, so I'll just go to that commit. So if we do this, we can say git checkout. I don't have right-click, copy-paste. That's annoying. E6690, E6696. Okay. Now let's run git status and see what we've got. Test.cc is modified. All right. What is it modified to? Aha. Now I have my AAA back. Great. And moreover, it's automatically staged it for me. Wonderful. Yep.
Is that considered a new change, though, to your file? Like, will that be considered the most recent change?
All right, so the question is, will this be considered the most recent change? And the answer is, well, Git doesn't acknowledge that we've changed it until we commit it. Currently, it's not committed. All we've done is we've gotten the file for ourselves, and from here we could make more changes to it if we wanted to. Up until the point where we run git commit, Git doesn't really care about this file. But what we will do now is we will run git commit. All right. And now we can run git log again. And we can see that we've added our new commit on top of things. That's great. This works if there's just one file that we wanted, or 2 files or 3 files. If you're working in a bigger repository, maybe a repository with 5,000 files in it, not uncommon at large companies, and you really want to get everything back to this old copy of things because maybe you ran a recursive delete and you deleted everything. Manually checking them out will take you a long time. And so maybe you're wondering, okay, is there an option that just takes me back to this commit entirely? Like, not just get me one file, please reset my state of the world to be back where that commit was. The answer is, of course, yes. And it's called git reset. In order to use git reset, we should probably first take a look at the git ref log. It's a lot more terse than the typical git log. All it has is these first few characters of the ID here. You recall I said that you usually only need the first few characters to tell it what commit you're talking about. And the fact that it's telling you this, it says, if you only type in this much, I'm going to recognize this as the commit you're talking about. That's fine. But it also gives you something even easier, which is the syntax head, at, and then in squiggly braces a number. Head refers to the current commit, where Git currently thinks you are. And then by saying at and then some number in squiggly braces, it means that many before. So head at 2 means 2 commits before where head currently is positioned. If you were to draw it out, it would be like taking that tree over there and just dropping it 2 down. All right. So say I change my mind again. I'm a very indecisive person, and I do want to go back to foobar. But I don't want to do it with checkout. I want to do it with reset. I want to go back to this point in time, right after I had changed that, done that merge commit, because that's when I added the foobar. So I want to reset to head at 1. Now if we do git status, or rather test.cc, we see that we're back at foobar. And you'll notice here I didn't just run git reset head at 1. I ran git reset -- hard head at 1. There are 3 kinds of reset, of changing hardness. Most of the ones you will ever use in your life are git reset soft and git reset hard. What git reset hard does is it says, you know what, I don't care about any of this that I currently have, just take me back to that old commit, that's all I want. Git reset soft says, well, take me back to that old commit, but all these things I've changed but haven't committed yet, don't modify them. I want to maintain those changes, but I also want to be back in that old commit. So that might be useful, for example, if you just change a couple files and then you want to go back to where some other files had been unmodified. It's harder to find a use case off the top of my head for git reset soft. You can probably imagine some use cases for git reset hard, usually when you mess something up royally and you just want to go back. And now if we take a look at our git stata, or our git log rather, we see we've reset and we've brought ourselves back to this point in time where we did that merge. We could reset again. You can reset anything. You can reset resets. It's wonderful. Git is a smart program, and there's unlimited things that you could do with it. All right. I'd be remiss in going a full Git tutorial without mentioning probably one of the most notorious features of Git, and one of the nicest ones, which are branches. So all we've been doing here, we've just been modifying this one line. We make some changes. Occasionally we push it to the server. Sometimes we get stuff back from the server. A more useful way of thinking about the relationship between the server and our code is as 2 branches. So for example, this is what our code looks like. We're here, then we make a commit. We get here, we make a commit. We get here. And now, maybe for example, our server is here. When we merge, or push rather, our code into the server, we can think of that as pushing this into the server line. So this is the server, this is us. And so now if we had someone else, for example, maybe they make a change, maybe they get the code from the server here, they make a change, they push it back to the server here, and then maybe we get the code back from the server here. Or, yeah. You can see that this quickly gets confusing. However, let's just forget the server part of this for now. And the someone else part of it too. What we're interested in is the fact that we sort of had branches off of this main branch here. So instead of this being a server, what if we just had, another pseudo Git repository that had the same files. We could make changes in here, a bunch of changes. When we were satisfied with it all, we say, you know what, this is good enough to go in our gold code. We'll put it back up here. And perhaps a useful way to think of this is as versioned releases. So maybe this is version 1.0, this is version 1.1, this is version 1.2, and this is version 1.3. If, for example, we were adding graphics into our game, maybe this is the part where we open a window. This is the part where we actually draw things on the window. This is the part where the graphics are actually fully working. We could put that on the same line as this. There'd be nothing wrong with that. It would be kind of awkward if I was a user, I went to your website and I downloaded the most recent version of your project, and I got this totally half-implemented, super broken version of graphics. I'd rather just have no graphics up until the point where it's done successfully. And so that's the idea of a branch. This down here is an additional branch that we've created. And in this branch, we can do a ton of commits, as many as we want, without affecting this main line here. And finally, whenever we push it back in, this will get all the commits at the same time. If you've been seeing master pop up all around the stuff I've been doing in this tutorial, the reason is because every Git repository starts with a single branch, and it's called master. If you make any additional branches, you can name them whatever you want. But this master one is always the one that users will get from. Similarly, whenever we're doing git push to push our code into repositories on the server, we're pushing it to origin/master, which is the master repository on GitLab. You can also set up GitLab to track your branches that you have locally. So for example, other developers will be able to see your changes in here and add to them. But ultimately, you can all keep those changes isolated in this local branch up until the time where you decide, you know what, this is good enough. I want to put this in master, and you do exactly that. Now, I don't know why they did this, but Git decided that it would be a really good idea to overload some syntax whenever it comes to working with branches. And so they did. To create a branch, intuitive enough, maybe I want a new branch name, git branch, my new branch. We've made a new branch. Now, maybe we want to see what branches do we have. Well, you can just run git branch with no arguments. We have two, we have master, we have my new branch. The star beside master, that means that we're currently on master. How do we get to my new branch? Well, we use checkout. Yes, it's the same checkout that you use to get files from other commits. If instead of a commit number and a file, you provide it with a branch name, it's going to move you onto that branch. Not the most intuitive. So now we're on branch, my new branch. We can make some changes in here. Now the true test of my Git skill is if I remember how to merge this branch. If I'm not mistaken, it's just git merge and then the branch name. So hopefully that will work. We'll go back to master. And we'll say git merge my new branch. Woohoo. Now if we say git status, you see we have nothing weird happening. However, if we do git log, we will see that we've pulled in this commit that we did on our branch. we've merged it into our local, where we have added test2. And indeed, if we check out what's going on in master, just by doing a listing, we'll see we have test.cc and we have test2.cc. And we can push this all to the server. And now it will have made all of those commits we have, it will have put them back. And you'll recall that's where we changed to AAA, and we made our merge conflict. We resolved the merge conflict. We reset things. We branched off. We made a new file. We merged the new file in. That's a lot of stuff. If we go back to Git, well, we'll see that not much has changed, really. But we do have this test2, so that's nice. Now, one use case of GitLab that you'll probably want to get into is, actually, you know what, before I get into that, one more Git-specific topic is a .gitignore file. This is a useful one. It's rather annoying whenever you're working on, when you're working on C++ code, that's all you want in your Git repository, really. It's C++ code, right? I mean, who cares about the .o files, the executable files? I don't want them in my Git repository. Why do I want that? They take up space, and I can just build them from the C++ files anyway. So what am I going to do? Am I going to run make clean before every single time I do a commit? I am too lazy to do that. Instead, I propose a better solution. It's called a .gitignore file. It just sits inside your Git repository, and inside it you can feed it a bunch of globbing patterns, and you say, if anything matches these patterns, pretend they don't exist. I do not care about these. The most common way you'll use a gitignore file is by giving it a bunch of file extensions, like so. It's like this. It's a dot file is one thing, just to make it hidden, because it's kind of ugly having this file everywhere. So it's a dot file. And then since I'm a C++ project, well, what are the things that I want to not have? Well, I don't want my dependency files. I don't want my object files. And I don't know, depending on the project, maybe I don't want sorcery, because I don't want the executable committed. Great. Now we can add the gitignore and commit it. All right, now let's make a dependency file just for fun. And if we run git status, it tells us that the working tree is clean. Well, there's stuff here, certainly. There's that test.d. That's brand new. We'd expect Git to recognize that. For example, if we made just another random file, and then we ran git status, well, Git has noticed that ABCD is an untracked file. It doesn't notice that test.d is an untracked file. The reason being .d is something that gets globbed by our .gitignore file. And so Git says, you know what, I notice that this exists, but I'm going to ignore it for you because you told me to. If you're not seeing your files added for whatever reason, make sure that you have the right extensions in that .gitignore file. Otherwise, it will fail very silently for you. All right. There are a lot more things Git can do. This just scratches the surface of some of the commands available in Git. The ones you might find yourself using in day-to-day as a software developer or whatever are cherry pick, which roughly speaking allows you to pull changes from a commit into your current commit. So you could cherry pick one commit off a branch. There's rebase, which is similar to merge, except instead of merging all the commits at once into one big massive commit, it blocks them into applying each commit one by one onto your current branch, which is nice if you're working. It depends on your workflow. Sometimes rebase is nice, sometimes merge is nice. It really depends. Git diff is a way of checking what's changed between two commits. You say git diff, you feed it a commit number and you feed it a file, and it's going to spit out what's changed between your file in your current commit versus the commit that you asked me to look at. Two last ones. Git blame. Git blame allows you to look at a line of code and figure out who's responsible for it. Wonderfully named. It doesn't have to be an accusatory sort of thing. It can be nice. If, for example, you use Vim, maybe some of you do. I use Vim. There's this wonderful Git plugin for Vim, and you get this access to this command, gblame, and what it does is it pops up this window beside, and on every single line of code, it has the git blame output, so the username of the person who last modified this line of code, which is wonderful if you're doing work in software development, because if you see a line of code and you think, what was this person thinking? All you need to do is :gblame. It's going to pop up, and you can go yell at them or whatever. And one nice commit. Earlier in the course, you saw grep. Grep is useful for searching for regular expressions inside files. Grep is less useful for searching for regular expressions inside massive directory structures because you've got to think, well, how do I get the right files to search through? If you put a git before it, you get git grep and git grep. It just does grep, but it searches every single file that's tracked in the current Git repository. So for example, I could use git grep on that repository I just made, and it wouldn't search the .d file, which is good because it gives us the ability to use grep effectively globbing over every single file that we care about. So that's another nice one. The last thing we can take a look at is, well, I suppose it would be instructive to see how can you make groups on GitLab, since these private repositories, they're just for a single person. You can't add friends to your private repositories. It does not work that way, unfortunately. What you can do is you can make a private group. You can add your friends to the private group, and then you can make a private repository in that private group. Yes, it's a bit of a confusing workflow. All right. Intuitive enough interface. Click this new group button. Like so. Visibility level. This one is public by default, but you'll almost certainly want to set it to private. You do not want other CS246 groups to be able to see your code, presumably. And you get this little blurb about what groups are at the bottom. A group is a collection of several projects, whatever. And when we have that all done, we'll say create group. Now in here we can go to members and say I want to add a user to the group, like Nomer. Well, I won't actually add him to the group because I don't want him getting annoyed at me. But if I did, I could set an expiration date after which he will no longer be a member of the group. Then I'll just click add to group there. Then Nomer would be in my group. And you can fill in any user here on the Waterloo GitLab. All you need is their quest ID. And then back in group, you can say, make me a new project. And now you can have this private level, which is going to be private to members of the group, which is exactly what we want. So now by doing this, we have a way that all three members of a group will have this free private Git repository that they can collaborate on, owned entirely by Waterloo. You don't have to worry about Microsoft stealing your code or whatever if you put it on GitHub.